So I am going to speak today on disruptive automotive technology, trends and skill development. So you must have heard of how India is moving forward. India is building automobiles. India is the fifth largest automotive manufacturer in the world. We produce 25 million vehicles every year, and there are a lot of vehicles which are exported. Around 3 million vehicles are exported. So I would like to give you my experience in the field of automotive technology. You all know that in the last 2 years, the world is shifting towards electric vehicle. So we are talking about autonomous vehicles, connected vehicles, electric vehicle, and shared mobility. And in India, Ola, Uber have become very famous. Electric two-wheelers and electric four-wheelers have started emerging, not as big as China, but it has started. Slowly, the penetration of electric vehicles are going to increase in India. So worldwide, people are talking about ACES, autonomous, connected, electric and shared mobility. And what is important is that we need the last mile connectivity. So if you are traveling in a train, you get down, then you must be able to travel in a two-wheeler or an auto rickshaw or a bus. So what is important is whether we walk, whether we bike, whether we ride, or whether we drive. It is very much essential that we must be able to reach our destination, whether it is a college or whether it is an office. And hence, we need to work on a scale where we are able to integrate all these mobility options. So in the Asian context, whether it is India or whether it is Nepal, the context slightly changes. The ACES is not autonomous but affordable. A stands for affordable solution instead of autonomous, because there are many who are at a lower income, and hence they must be able to afford vehicles, two-wheelers and four-wheelers. Then there is a lot of congestion and a lot of traffic taking, a lot of accidents taking place. So it is necessary that we must be able to connect, each vehicle must be able to connect to each other. When you cross a toll tax, the toll also must be deducted automatically. And there has to be a shared mobility. Because our vehicle, we use only 5% of our vehicle. When we go to office or when we go to university, we park the vehicle in the night, we park the vehicle in the campus. So we use only 5% of that vehicle. If we have a shared mobility, then we don't require so many vehicles. The same vehicle can be reused again and again. Third is this automobile are giving a lot of pollution because of IC engine, and we have to get a lot of crude petroleum for the same. So we need to have environmental friendly and energy security. And the last is we need safety. Our vehicle must be safe and number of accidents must reduce. So ACES remains same. In global context, ACES stands for autonomous, connected, electric and shared mobility. Whereas in the Indian or the Asian context, just 1 minute. Amita, my lecture has started. I'll talk to you later on. I'm in a lecture. So, in the Asian context, whether it is India or Nepal, affordable, connected and shared, eco-friendly and safe is the new concept which we have put forward, and we need to work in those areas. Quickly, I will run through the technology trend. I'm going to go very fast because I have 85 slides and I have to finish it in 45 minutes. So half a minute per slide. But I will be very happy to share this presentation in case somebody wants. I will email it to the organizers and that can be shared. So first and foremost important is safety. Whether it is safety related to windshield, whether it is safety related to adding crumple zone in the car so that when the car dashes on the wall, the driver is not affected. Use of seat belts, use of helmets, use of head restraints are all becoming compulsory. India seat belts in all the front also and the rear also are now provided in the car. head restraints have become very common, airbags have become very common. Occupant safety is one area where we need to do a lot of research. And all these areas, whether it is active safety or passive safety, are inbuilt in the Indian car. And now the new NCAP safety is also done. So the crash rating is also done these days for all the cars. We need to start working towards intelligent vehicle technology. If we are not able to make autonomous car, fine, but we must work on technology where vehicle will be able to talk to one vehicle will be able to talk to another vehicle, accidents would reduce, and the traffic would also reduce. So intelligent vehicle technologies are very much required, and these cars have a lot of sensors, a lot of actuators. So we need to understand that we have to add a lot of sensors and actuators. We need to have a lot of ECUs, one for engine, one for safety, and one for electronics, and so on. So series of sensors and actuators and ECUs would be required to make car more safer. Then we need to use techniques like radar, lidar, or sonar to detect various ranges, to detect various objects, so that the accidents are minimum. Connected vehicle is another area where one vehicle talks to another vehicle, and most of the time we use dedicated short range communication, which are popularly known as DSRC. And so there is a need to understand in-vehicle monitoring, real-time notification, and for this, diagnostics and prognostics have to be stronger. So we need to now start teaching all these things in engineering colleges. In terms of data science, which is a multidisciplinary field, we need to work on hardware, software, and various algorithms. And then we talk about artificial intelligence. This is becoming more and more important. The car must be able to see, the car must be able to hear, and the car must be able to talk. And that is all possible. So artificial intelligence is going to play a very major important role in our life, whether we use our mobile, whether we use our car, or at home. Artificial intelligence is something which is going to come very fast, and all of us, even in Asian countries like India and Nepal, we need to start learning this. So we need to start working on Python, machine learning, and so many things, right? So we need to learn on artificial intelligence systems, and we need to learn various machine languages, and then work in those areas. So you would see that if you want to make an autonomous car, you have to rig up the entire vehicle. There has to be a lot of cameras around. There has to be a GPS system, and there has to be a radar, and if it must be able to find out the obstacles, and so on. So we may require more than 4,000 GB per vehicle. And if we are able to do this, then we will be able to make an autonomous car. An autonomous car sometimes may become very useful in any confined area where the traffic is comparatively lower. So Dubai has already started using autonomous car for their taxis, whereas it is still not started in India. We are working on it, but up till now, the government has not approved it. So ARAI has been very much instrumental in demonstrating an autonomous car. So there are various levels of autonomy, and we must start with level 1. So in Nepal, like you have level 0, then you have to start working on level 1 and then slowly shift to level 2 and so on. Finally, the driver must get some relief, and he must be able to do hands off, and driver can sleep for some time. Eventually for level 5, the driver may not require, and the seating position inside the car may totally change. Maybe the seating position will be circular because driver is not required to see the front. So worldwide, there has been a lot of problems in terms of economics. We have to buy crude petroleum, and the prices are rising. The society is subjected to rural area and urban area, and more people are shifting to urban area, leading to very high traffic and urbanization. and hence we need to work in areas like electric vehicle to reduce this dependency. There are various strategies and policies declared by the government in terms of emission norms, in terms of CO2 emission, in terms of safety, and we need to take care of our environment, and we need to know that this climate change can lead to global warming and can lead to health hazards. So there are various protocols. Kyoto Protocol is the latest one which we have signed, and we are committed to this social change. And hence, one of the mobility mission could be electric vehicle. Electric vehicle are the simplest vehicle which we can implement in place of IC engine vehicle. Initial cost may be high, but with increase in mass production, the cost will drastically go down. So whether you use a pure electric vehicle called a battery electric vehicle, or a hybrid electric vehicle, or a plug-in hybrid vehicle, or fuel cell vehicles, all are different. Okay. So basically in an electric vehicle, what we need is a lithium-ion battery, and through controller, this will convert DC into AC and feed to the electric motor, and through the gearbox, the drive may be given. So this is a typical battery electric vehicle, and you can see that there is a motor, there is a battery pack, there is an inverter, there is a battery management system which will take care of all the charging and so on. So basically there are four pillars of electric vehicle. One which is the motor, another the storage system like battery, third is the power electronics, and fourth is the energy management system or battery management system. So we need to work on four of these areas, and we need to understand the degrees of hybridization. It can be just start, stop, go, or it can be more and more involvement of electronics, and then we may have a very high degree of hybridization. So there are electric motors, different types of electric motors, and electric motors have to take the load and take it forward. So this is a typical electric motor, and you can see the stator inside, you can see the rotor, and so on. So this is how the final typical motor will look like. So there are different types of electric motors: permanent magnet motor, induction motor, switch reluctant motor, SRM motor, and so on. And each of them have some advantage and some disadvantage. For smaller vehicles, the requirement may be different, and for a bigger vehicle like utility vehicle or bus, the requirement may be different. Most of them are using induction and permanent magnet. Very few are using synchronous reluctance magnet. So permanent magnet is one good choice. So one must learn the characteristics of the electric motor, and one must know that when the power is very high, the torque may be low, and vice versa. And we need to work on the optimization of the electric motor. And when we select an electric vehicle, we need to understand the vehicle specification. We need to understand the required specification. We need to understand the motor and the motor system. Yeah, so that's about the electric motor selection criteria. Yeah. And we need to work on various design aspects. So what are the challenges in terms of cost and performance, and what are the various design options? How do we ensure cost, performance, and life are joined together to be an interaction which will decide the technology for the today's. So electric motor design, we have series of software. For example, Altair has series of software where electric motor design can be helpful, and there are various challenges which we need to meet, and the value for the money. So electric motor design is one of the most important and critical. So it includes electrical, it includes fluid dynamics, includes vehicle dynamics, and so on. So here you can see that the motor design workflow, we start with the analytical design, then go do a FEA, then do a thermal and structural integrity, and then become a system analysis. So electric design workflow plays a very important role. Then which countries are good? For example, India has recently signed MOU with Argentina and Bolivia for import of lithium-ion material with them. So we need to brush up and we need to move fast in this area, whether it is two-wheeler, three-wheeler, or four-wheeler. So in short, talking about electric vehicle, there are different types of electric vehicle. The one which uses a central drive, one which uses a wheel hub drive, and so on. The one which is a wheel hub drive derivatives. So the configuration of electric motor, once it is known, then the power electronics will help the motor not moving in the restricted area. And then we, in terms of power electronics, we have material from inverters, DC-DC converter, and rectifiers. So design of power electronics and control design is another such big area, and at component level, this may be useful. Yes, this will ensure short-term protection and assessment of mechanical reality and optimize. It will also help in optimization of the thermal management. Energy management system, or popularly known as battery management system, has to be incorporated into the vehicle, and in some area it has to control, some area it has to take decision. Then the battery storage system, battery also is very difficult. So we have done experiments with the batteries where we have given different treatment to those batteries. And based on that, we have done series of experiments. Right now at ARAI India, we are developing various batteries and being tested at National Chemical Laboratory, NCL, Pune. So in terms of battery terminology, one must know what is SOC, what is DOD. For example, SOC is state of charge, DOD is dispatch of discharge, and so on. So battery terminology and battery thermal analysis, both are very important. And let's go to the next slide. So the person who invented lithium-ion battery is a Nobel literate. Sorry. His name is John Goodenough, and John Goodenough is also a professor. So never underestimate a professor. He has been, hello? Hello, am I audible?
Yes,
Yes,
sir,
sir, you
we
are
can hear
audible.
you.
And
We can hear you, sir.
Fine. So, Professor Dr. John Goodenough has done extensive work in the area of battery, and he has invented this lithium-ion battery which can run for a longer life. Moreover, he has worked on some more ideas of batteries like glass battery, and in future more and more people will start using glass batteries, if not in 2021, in 2022. So that is being given shape for the batteries. So there are different types of batteries. Some are conventional, some are lead acid battery, some are lithium-ion, nickel metal hydride, and metal ion, so on. So the battery shape can be circular, that means cylindrical, or it could be a pouch cell, or it could be a prismatic cell. So when you talk about a cell is a unit with positive electrode, negative electrode, and electrolyte. And when you club all those cells, it becomes a module. And when you club all those into one module, it becomes a battery. Okay. Then comes the battery designs. And so there are different shapes and size of the battery pack. You require a cooling around those battery pack. You require thermocouples to be connected to the battery pack. And thus battery design plays a very major role. So there are various softwares used to design the batteries. But I would say simulation, design optimization, and reliability of the entire E-kit is more important, and then comes the optimization of the battery system. Okay. So you can see that some of the batteries can be very difficult to understand in terms of energy capacity and power capability. So different vehicles need different cell types. High power cell needs hybrid vehicle, and high energy cell needs electric vehicle. So you will see that the pink portion is more for electric vehicle and the blue portion is more for the hybrid vehicle. Okay. So there are different types of material used in the battery. We started with lead acid battery, but now we are talking about lithium cadmium batteries and nickel metahydrate batteries also. So we need charging stations. So there is a lot of anxiety related to electric vehicle, that okay, we will buy electric vehicle, but where are the charging stations? So India is working very strongly on the type of charging system used for electric or plug-in hybrid vehicle, and we need to work in these areas and ensure that we can charge faster, which can give better range. So in terms of AC charging, we have different types of AC charging, and we will be able to show the demo also. Okay. So there are various standards on EV charging standards. It will take care of safety, scalability, saving, security, and simplicity. So if we need to work in these areas to ensure that EV chargers are also safe. So here you can see that the EV charger is in the center, and we need to work on various standards, IEC standard and ISO standard and BIS standard. So ARAI has developed their own charger, and this technology is available for sale. So if anybody is interested in Nepal to manufacture standard battery charger, then we can help them. There are also areas where, one second, where the charging can play a major role, and hence it is very much essential that the vehicle must be charged regularly. So India started working before 20 years. So somewhere in 1999, the first committee was formed from various organizations to work on electric vehicle. So you can imagine that electric vehicles, you have seen it now, but India has strongly advocated electric vehicle and this type of grassroots level. So there are various norms and standards, and I have subsequent slides where I want to talk about standard. But now retrofitment has become very important. Retrofitment of e-kit, whether it is two-wheeler, three-wheeler, or four-wheeler, we need to work on that. And besides retrofitment, we need to work on charging stations, on hybrid electric vehicle or electric hybrid vehicle. So the most important notification which has come in India, there are two notifications. One is called swappable battery, and then one is called retrofitment. So the swappable batteries are used to reduce downtime, and all these regulations are very important for any electric vehicle. So when we are talking about electric vehicle, we have to be very, very careful about the fire hazards, heating up, and so on. So we need to do various validation tests like a water welding test for an auto rickshaw, or EMI EMC test, or the crash requirement. So when we do a crash test for an electric vehicle, we need to take some additional responsibility, and that is also done at ARAI. ARAI before 6 months have inaugurated its Center of Excellence on E-Mobility, under which we do series of training, and we also do training for the employees. So that is about the ARAI Center of Excellence. And now with this background, I will take the next slide of what type of research we can do in Nepal, right? What type of research can we do in Nepal? Can we make concepts? Can we work on modeling, simulation, and optimization? Can we make a prototype? Can we make EV retrofit kit? Can we work on battery swapping? Can we make battery management system? And can we do system integration? These are some of the questions which are being asked. And if we can try to address these questions, it would be great. So if somebody is interested to work in this area, whether he is an academician, whether he is from industry, or whether he is a student, we need to start with this area where not much equipment is required. We have a lot of simulation technology. We have a software from a company called Altair, and there are a lot of companies who gain through this sustainable solution. Okay. So whenever we want to do product development, whenever we want to become a startup, say somebody of you may wish that I will make an electric two-wheeler, or somebody may wish that I will do an electric four-wheeler. They have to do a rigorous product development. That means they start with what should be the specification of the vehicle, what are the requirements, what do the customer want, and then start working on the system, functional and architecture design and subsystem design, and do a detailed optimization. Component integration and verification, early reliability and verification, and system validation will go hand in hand. So for those who want to work in the field of electric vehicle, there are a lot of research trend. We can work on the architecture of the electric vehicle. We can work on the electric motor, how to get maximum efficiency and maximum speed. Working on electric management system through BMS, big data and artificial intelligence area, in-vehicle networking area, and on the extreme three, there are more related to batteries and the software and the battery charging system. So this entire ecosystem will help India to move forward in field of electric vehicle. There are different types of electric vehicles. You can do research on them. You can do research on EMS, energy management system, through its strategies. You can work on energy storage solution, and you can work on different types of batteries. Smart charging solution is very important. You must be able to charge near a restaurant. You must be able to charge near a mall or a theater, and hence we need to work in these areas. It could be also the outcome could be regenerative braking, or the outcome could be a safer society, and so on. So there are different types of charging, and one must be able to differentiate what type of charging is required. India is coming out with a new regulation of battery swapping solution. Say if I buy a bike and the cost of the bike is 1.5 lakh rupees, then out of that 1.5 lakhs rupees, 50,000 itself is the cost of the battery. And the battery cost needs to drastically go down. And that is all possible with more and more people buying electric vehicle, so that they are tempted to reduce the price slightly. Intelligent solution for charging is also very important. What do we do on the vehicle, the solar panel, how fast we can be. All those areas are something which we need to work on. So using an electric vehicle, we can store energy, and using our technology infrastructure also, we can store energy. Then we have framework for grid support by battery manufacturer. And how do you work on those battery manufacturing? Use batteries from electric buses, get a second life, or V2J could help EV battery flying. Okay. So with this, now I have only last 10 slides and I'm going to talk about skill development and then stop here. Uh, is that fine? I can complete the 10 slides? Okay. So if you look into the area of skill development, all this disruptive technology, whether it's electric vehicle or whether it is connected vehicle or whether it is autonomous car, we need to learn a lot of softwares and hardware. Otherwise, this may remain a black box for us, and we may not be able to contribute to the back to the society. So it is very much essential that everybody's skill needs to be developed. Whether you do skill development of 1 hour per day, 4 hours per day, if you're a teacher or a professor, it would be 8 hours a day. But even if you are not teacher and professor, you can cultivate this habit of reading good books. So disruptive technologies are driving the need to bridge the gap in workforce competency. Automotive Skill Development Council, where I am the chairman of the electric vehicle group, has strongly recommended that electric mobility should be immediately applied. And the future of the success of the automotive industry is workforce. So we must be very careful to train and retrain this workforce for the year 21-22. So reskilling is another area. So if somebody is good in IC engine, he need to learn electric vehicle, and he must be able to get good score. And if he or she is not getting good score, then probably it will be written back. So what is important is in reskilling, there are various respondents. A survey was done, and based on the survey, it was found that majority of the organization expect that there is a big skill gap, and we need to invest in this skill gap to come out of this. Because if the technology is going to move faster, so whatever happened in last 100 years to the automobile may drastically happen in last 10 years to the automobile. The automobile itself will change drastically, and hence we must be able to reskill continuously. That means we need to be in the learning process continuously. So survey conducted by McKinsey shows that majority of the companies are facing technology and or market disruption affecting more than 25% of the current roles. So today, 25% of the population or 25% of the engineers working in any organization have become redundant. They are of no use. They are like furniture in an organization. We need to work in this area, and we need to ensure that the skills are developed. So whether it is India, whether it is Nepal, we have to make a vision plan of skill development where people must be able to learn what is safety, what is emission, what is fuel economy, what is CO2 emission, and how do you implement electric vehicle and connected vehicles and autonomous cars in Nepal. So yes, there is a group called Faculty 73 VW. Volkswagen have taken a decision to spend 73 billion euros. You will not imagine 73 billion euros Volkswagen itself is going to spend on future technology over the next 5 years. So it won't be surprised that around this 30-40% of the people who are redundant will maybe asked to leave. And people like Daimler have doubled down on austerity as electric era becomes. Companies like Cummins, who makes only engines, are worried that our engineers must learn electric mobility, otherwise they cannot move forward. So workforce has been given a very, very important area. Skill development is a very important and very, very near to the heart of the Prime Minister of the India. Okay. So in India, from last 6 years, we have been conducting an event called E-Baha. We have been conducting M-Baha, that means the normal Baha Essay India from last 15 years. But before 5 years, we went and met our president or Dr. APJ Abdul Kalam. And he said, no, you don't just use a petrol or a diesel engine. You must use something different to improve the quality of the event. And that's how we started working on electric Baha from last 5 years. And more than 50 teams apply every year and make their electric cars. ARI has been contributing to this e-mobility ecosystem through various awareness programs. So through the Government of India, Department of Heavy Industry, we are conducting electric vehicle awareness program. So we must have trained more than 5,000 students by now in various engineering colleges. And we have developed certain qualification packs with ASDC, Automotive Skill Development Council, where we can share with you how would a technician look like, how would an electric vehicle driver look like, or how would an electric vehicle sales consultant look like, and so on. So we are here to create a very strong encyclopedia through this QPs and through this PIPs, Proficiency Improvement Program. Yes, we started last year a 1-year postgraduate diploma in electric mobility, where 20 students from each 3 colleges can join this program. And we also have an Emitec program in electric and hybrid vehicle. And finally, we have a postgraduate diploma in electric and autonomous vehicle at Sangli. So we started working on electric vehicles before 2 years, and we started working on autonomous vehicle from last year. And that's how the technology is moving fast, and we need to go. We must have conducted at least 25 training programs in the last year, all of them related to electric vehicle or hardware or software. And hence, many of my colleagues from Nepal were able to join online for such training programs. So more and more training programs are being planned. And what I would like to conclude saying that the latest disruptive technology talks about less usage of crude petroleum, shifting towards conventional fuel, that is petrol, diesel, and slowly shifting towards alternate fuels like LPG, CNG, electric vehicle. And then finally, we will be able to reach our final goal, where hydrogen is a technology. And we need to reach this goal. So right now, say for example, Nepal may be on alternate fuel, India is on hybrid and electric vehicle technology, and we must be able to catch up to the world faster. So with this background, I stop my presentation here. So in case you need any help, my email ID is here, vora.pga@araiindia.com, and we will be very happy to help you in the area of electric mobility or any disruption. And we will be also happy to help you in skill development. So if any students from Nepal wants to come to India and do a post-graduation or an undergraduation or a postgraduate diploma, please feel free to contact me. My email ID is vora.pga@araiindia.com. And I am a strong supporter of industry-academia interaction. And industry and academia interaction has to be stronger so that the students get benefited. Thank you very much.